Muhammad Salim from Pamir Private School, mathematics teacher. So in this session, we will discuss here a type of matrices. As earlier we discussed here how we can how we can define the matrices and how we can present in that mathematical form. So over there we discussed how we can write the matrices and how we can define, and also we learned how we have to order the matrices or what are the order of the matrices. Now we have to define here what are the types of matrices. The first one we have here a row matrix. As we know, we have to write in the form of a rectangular. In the rectangular box, we have to write the entries of the or a data we can write in the form of a rectangle. When we have only a row matrix, so we have to write all the entries in the form of rows only. So here, like we have the definition of the matrix is written there. Here we have a matrix M. That matrix M we have to call as the row matrix. Here the rows are present in the form of horizontal line and vertical lines that present here the columns. So here it's mentioned here a row, we have only a single row, entire row we have to call as the entries we have 2, -1 and 7, and the columns that are present here 2, -1 and 7. The order of the matrix is given here 1/3, and it is same here. We have the matrix M with the order 1/2, so that we have to call a row matrix. And then we have a column matrix. Column matrix we can define as when we have only a single column. So then we have to call that matrix as a column matrix, as it is mentioned here in the example. Here we have order of a matrix that we have 1 column and 2 rows, and in second matrix we have 3 rows but only we have a single column. So that we have to call that a column matrix. Order of the second matrix is given as respectively we have 3 cross 1. Now moving forward, we have a third type of a matrix we have to call a rectangular matrix. A rectangular matrix we can define as when we have a different number of rows and columns are present in the rectangular box. Like examples are given here. The first one, like we have a matrix A. Here we have the 3 rows that are mentioned here. Row 1 we have the entries 1 and 2. In the second row we have entries of 1 and 1, and then we have in the third row we have the entries are 2 and 3, and we have the 2 columns. As we have the first column, the entries are 1, 1 and 2, and in second column we have the entries are 2, 1 and 3, and respectively we have in the matrix B and matrix C. So these are the examples of a rectangular matrix where we have a different number of rows and columns, means the rows and columns are not equal. Here the order of the matrix are 3, 2. In the second matrix we have 2 rows and 3 columns, and in the third one we have 3 rows and 1 column. In the third one, as we have the matrix C, we can call that also a column matrix because it's having only a single column. Now moving forward, we have a square matrix that is quite opposite to the rectangular matrix. As we studied in the rectangular matrix, we have a different order. In the square matrix, we have a same number of rows and columns, means the number of rows and columns are same in that matrix. Examples are given here. As we have mentioned in the first row, in the first column, matrix A, we have 2 rows and 2 columns, and also like for example here in the second matrix B we have 3 number of rows and 3 number of columns, as we can written as R1, R2, R3. So the order of that matrix is 3/3, and then we have a null matrix. Null matrix, when we have the all entries of the matrix are 0, so that we have to call a null matrix. Now moving forward, we have some exercise questions for you. Here we have to identify the types of matrices. Here we have to discuss a row matrices, unit matrix, column matrix and a null matrix. Here the examples with the solutions are given here. As the first one, we have the entries of the matrix are all 0, so that's we have to call a null matrix. And then as we have the matrix B, it's said we have only a rectangular form. We have only in the entries of the matrix P that are present only in the form of rows, so that we have to call a row matrix. And then we have a matrix C that present in the form of column only, so that we have to call a column matrices. And then we have a D matrix, we have to call that's a special matrix, we have to call a unit matrix. And then we have again null matrix, same as we have matrix A. And then we have F, we have the column matrix in the given example. Now we have the transpose of a matrix. Here we have to decide how we can change or what are the transpose of the matrix. Transpose of the matrix, we can change the rows or the columns in like we have to interchange them in the form of rows or in the form of columns. And we can denote as a raised to power t, as is given here. Now the examples are, like for example, here we have the matrix B. The exercise regarding we have transpose of the matrix. As the first matrix, it is given as the matrix A. We have the column matrix, as you can see here, the matrix entries are 0, 1 and -2. Here we can mention here the order of that matrix is 3 rows and 1 column, so that we have to call a column matrix. So we can write that in the transpose of the matrix, as I told you, we can transfer this row or column. Like for example, we mentioned here the column. So when we will write this whole column in the form of row, so then we will get transpose of that matrix. Or it's a vice versa, like for example, if we will take this column in the row form and the second column we can write in the row form here, and then the third column, as we have the single entries, so that's -2, we can write in the form of rows. So there we get a transpose of the matrix. Like from here, the transpose of the matrix we can write in that form. Now the second example we have here, B matrix, that's we have a row matrix. The entire row we can convert that in, for example, if it is a row matrix, when we have to write in a single matrix, we can write in the column form, so that we get the transpose of the matrix. Now the third example, we have a matrix C of order 3 cross 2 or 3 by 2, where we have the 3 rows and 2 columns. So when we have to write all in the rows in the column and or column into rows, then we will get the transpose of the matrix. As like for example here, rows, that row we have to convert into the column. Like here we can write here transpose of the C matrix. That row we have to write in column form 1 and 2, and then the second row we have to convert this in the column form 2 and -1, and the third row we have to write here, like for example 3 and 0. So then we will get the transpose of the matrix as it's given here. And the matrix D, we have 2 cross 2. The similar way we can find the transpose of the matrix. The entries in the row form we have 2 and -1. We can convert them here. Now we have the second exercise. Here we can verify here when we will take the double transpose of the matrix or the same matrix, we will get the same matrix. As here, like for example here the matrix A is given 2, 1, 2 and 0 and 1. So first we will have to take the transpose. So the entire row 1 and 2 we will change them into the column, and the second row we will change them into the column as well. So first we get the transpose of the matrix. Now again we have to take the transpose of the matrix here, like here the row we have 1 and 0, we will write again them in the column form 1 and 0, and the second we have to write 2 and 1 also, that is a row form, we can write in the column form. So we will get the transpose of the matrix. Means here when we will take a double transpose of the matrix, so then we will get here transpose, and then again the transpose of the matrix will get the similar matrix A that's mentioned here. The matrix A we have 1 2 0 1, and the transpose of the matrix is also 1 2 0 and 1, which we have to verify here. The similar example here with the matrix B, we have matrix B, the entries of the matrix B are 1 1 2 and 0. Once we will take the transpose of the matrix, the row, either we have to take row or the column as it is mentioned here. We can look here, the row, either we have to write in the column form, or if we will take the column form into the row. So both have the same result. Now see here, the second row we have 2 0, if we will write in the column form, so we will get the same as if we will take this column into row form. So in both way, either we will change rows into columns or column into rows. So both we will get the same result. So that is basically the background of the transpose of the matrix. So either we have to decide which we have to take. Now the second, we will take the again transpose of the matrix B, the transpose, and then transpose of the matrix B here 1 1 2 and 0, which is similar as the matrix B we have. Now we have a negative of a matrix. How we can define the negative of matrix? When we have a matrix, we will change them into all with the negative entries. Like for example, if we have positive 1, we will the entry of the matrix is positive 1, we will change that into a minus 1. Or for example, if we have a negative minus 2 or minus 4, so we will write them in a positive form. Here we have the example, a matrix A, we have the entries of the matrix A are 2, minus 1, 0 and 3. So when we have, once we have to write the negative of the matrix, see here the positive value will change it into the negative, and here the negative value we will change it into the positive value, and here 0 we will change it into then we have a positive 3, we will change it to negative 3. So that we will write here the negative matrix as minus 2, 1, 0 and minus 3. Now we have the second exercise questions here. We will solve some examples here. The matrices are given here. Matrix A, the negative matrix of A is given here. Matrix B, we'll write the negative matrix of B. And now matrix C, we have 2, 6, 3 and 2, all are the positive. Once we will write the negative, so we'll change them all in a minus, means a negative form here. Now we have a symmetric matrix. First we will, it is basically we have a connected topic through the transpose of the matrix. Okay. Here we have the definition of the symmetric matrix. Once we will take the transpose of the matrix, if it came same as the matrix A or itself, so then we have to call a symmetric matrix. Means whenever we will take the transpose of the matrix, if it is came as the original matrix, so then we have to call that a symmetric matrix. Like for example, here we have the matrix A is 1, 2 and 3, and the second row of the matrix is 2, minus 1 and 4, and the third row is 3, 4 and 0. So when we will take the transpose of the matrix, transpose means we will change the row into the column. So then we will get the transpose of the matrix. Like for example, the row 1 we have R1 and row 2 R2 and row 3, these all rows we will convert them into the column form. So means we will get the transpose of the matrix. If we will get the original matrix, so then we have to call A is symmetric matrix. And now we have a skew symmetric. It is all reverse of this symmetric matrix, means when we have a transpose of the matrix will be negative of its matrix. So then we have to call a skew symmetric matrix. Here the examples are, for example, here we have the matrix A 2 3 0 2 3 minus 2 0 1 minus 3 minus 1 and 0. Once we have to take first the transpose of the matrix. If we have to look here, the all entries here will be the negative, as here see it's positive 2, it converted into negative, positive 3, it's converted into negative 3. Here we have a positive 1, that's convert into negative. Here we have a minus 2, it is turned into a positive 2. Here we have minus 3, that's turned into positive 3, minus 1, that turns into positive 1. So means here when we will take the transpose of the matrix, that become as the negative of itself. So then we have to call a skew symmetric. Here it's given. Now we have a diagonal matrix. When we have to call a diagonal matrix, when we have only the entries are in the form of diagonal. Diagonal means the slope form, and rest entries will be 0 here, as it is given in the definition. Here are the example here. Here we have the diagonal form. Diagonal we can write. And now we have scalar matrix. Scalar matrix is similar as we have the diagonal, but we have some property here using in the scalar matrix. When we have the diagonal entries are same, so then we have to call a matrix will be scalar matrix. Like here the examples are matrix A, all diagonal entries are same and order of that matrix is 3 by 3, and also the second matrix B we have the diagonal entries are 3 and 3, means they are same entries. Then we have to call them as the scalar matrix, as it is given in the example here. Now we have some exercise questions. We can identify here clearly with the definitions we learned here with the square matrix, rectangle matrix, row matrix, column matrix and null matrix. Here are the examples. We can identify clearly here. The first one we can recognize them through the order of the matrix, as we have the order of that matrix is 2 rows and 3 columns. So directly we can say here that's a rectangular matrix. And second matrix we can identify through the definition, as we know here when we have to write the entries only in the column form. So we will call them as a column or a rectangular matrix. And then we have a square matrix. The example of a square matrix, as we know with the definition here, when we have a same number of rows and column, and when we have a diagonal entries are same, and if it is unit, so then we have to call a unit or identity matrix. And then the last one we have here a rectangular matrix. Here the other examples are we have a rectangular matrix, a row matrix we can call, and then we have the similar as the second one, we can call that a rectangular or a column matrix. Specifically we have to call this as a column matrix because it has only a column. And then we have a square matrix because it has order 3 cross 3. And then we have all entries are 0, we can call that as a rectangular or a null matrix. Now we have the exercise question that we have to identify here diagonal matrix and scalar matrix and unit matrix. Here we have the first one as the entries of the matrix 4 and 4. So, when we have the same entries in the diagonal, so then we have to call that a scalar matrix. And then we have a unit matrix as it is given, the third one C, and then we have scalar matrix as we have. Thank you.